In this video, we are going to look at using Isotech Dry Blocks to test thermostats. The demonstration is with a fast cal, but the method applies to all dry blocks such as the Europa, Venus, Jupiter or Gemini. The first thing is to ensure that the thermostat is correctly connected to the unit. Simply connect the switch to the contact input on the front panel. We are setting the temperature of the block to a little less than the thermostat switching temperature. Here we start at 70 degrees and we are expecting the thermostat to change state at around 75 degrees. Now we need to adjust the set point ramp rate. To do this, press the scroll button twice, then use the arrow buttons to change the rate. This will ensure that the block does not heat up too quickly. For this demonstration, we are setting the rate to 2. To change back to the standard view, press the scroll button once more to save the change and then press the menu button. Now the unit is set up, you need to increase the set point to a little over the expected switching temperature. Now the block will heat slowly at a nominal rate of 2 degrees per minute. At the point the switch changes state, the value on the temperature indicator will be frozen and the lower display will scroll temperature frozen like this. In addition to this standalone method, we can also use a PC. We will now demonstrate this. Using a PC has the benefit of the data being captured to a log file, which includes the state of the switch. The graph shows the set temperature and the temperature as measured by the controller and the indicator. When the switch contact changes, the graph shows the temperature at the point of contact change along with the current indicator value. The software allows you to switch views of the data to the log file. The logged results can also be opened in Excel. Like the graph, the log file shows the controller value, the indicator value and the state of the switch. It also shows the times the recordings were taken and allows you to set how often you want a recording to be taken. Watching the screen, you can see that when the switch closes, the contact light turns green. The temperature at which the switch closes is indicated. The software shows the indicator value continue to rise, unlike the indicator on the unit, which will remain frozen. The graph will begin to chart a line at the temperature at which the indicator froze. Switching to the view of the log file, you can see that the switch state value changes from 0 to 1 to show that the switch is now closed. The final demonstration shows the use of set point programming. The set point programming allows the set temperatures to be changed with time. Enter the number of minutes to the first temperature and then the desired temperature value. This can be repeated as required. In this example, the block switches between 80 and 60 degrees, allowing us to test the thermostat several times.